ready for plan for the 8 one? Yeah. Okay. We started the topic of level of service and capacity analysis. We went through the definition of what we call as uninterrupted flow facility, the definition of capacity, what is level of service, and what do we mean by each level of service, goes from A to F. Okay, then we talked about the maximum service flow rate at each level of service. In this chapter we are dealing with freeways and multi and highways, and in both cases we need the same curve, the speed flow curve. Okay, so the curve starts with a straight line up to the break point. After the break point it dips, okay, and then it goes up to capacity. For the curve we find the equation, we find the speed using this equation, okay, and the break point and the capacity are taken from here. Okay, you see the equation for break point and you see the equation for capacity over here. Okay, some curves which are plotted for freeways and multi and highways. The values for density and volume capacity ratio for each level of service. For the given curve, the maximum flow rates for each level of service given in the form of a table. They are marked on the graph as well. In these analyses, we may need to perform some adjustments for weather, for incident, for work zone, and for driver population. Okay. Out of these four, only the work zone needs some calculations, which we did in the previous lecture. For the others, we have these sort of tables. So you just go to the table and pick your value. Okay. Moving on, if you have to find out the level of service, you must know some conditions of the highway. Okay, the current conditions of the highway. What conditions are listed here? Okay, they call them prevailing condition. Prevailing means the real, the current. Okay, so must know the lane width, the lateral clearance. Okay, the median type, the ramps if you have the freeways, or the access points if you have the mundane highway. Percentage of heavy vehicles and the what type of drivers you have. Familiar drivers, non-familiar drivers, and so on and so forth. Okay. Free flow speed can be found in two ways. Okay. Free flow speed can be found in two ways. One is what you already did in your projects. Okay. So you already found the free flow speed of the highway in your projects. Okay. Did you use any equation? Then what did you do? Distance over time. What do we call that study? Square speed study. Okay. So this is one method of finding out free flow speed, which you already did. If you didn't do, then we have equations to find it out. If you didn't do the square speed study, if you did the square speed study, that becomes your free flow speed. That's it. Okay. No other calculation required for the free flow speed. Okay. So I don't want to see the equation in your number. Okay, and not for your numbers. They are if you cannot do the spot speed study. This equation is applied to find out the free flow speed of our freeway. Okay, so you see there are three factors required in the equation. Okay, the first one is for lane width. The factor of lane width, not lane width. The factor of lane width. From where do I get the factor? The table. Okay, you don't put the value of lane width in the equation. Okay, now you see what is the minimum factor here? Minimum factor? 0, right? And what is the minimum lane width? Minimum lane width? 10, right? So if you put 10 in the equation, it's wrong. Because for 10, the factor should be 0. Got it? Clear? Sure. Okay. What is the maximum maximum value of lane width?
Or not enough.
So there is no maximum, right?
Yeah.
There is no maximum. 12 and more. Okay. The value will remain the same. The factor will remain the same. Okay. The next one is lateral clearance. Okay. Lateral clearance start from the last edge of the last lane. Edge of the last lane. Edge of the right hand side lane. Okay. This is from here the lateral clearance starts up to any object which you have. Okay. So for example, they have two lanes. At the end of the lane, there is a yellow line, and then after 5 feet, there is a sidewalk. Okay. Now yellow line means what?
Emergency line.
The emergency line, right? Emergency line means we should use it.
Yeah.
It's our birth right to go there.
To avoid the
To avoid
other channels.
to avoid other people. Okay, why they are in our way.
Kill some people who walks there.
Huh?
Kill some people who walks there.
Yes. Okay. But the point is, these people don't understand this. Okay? They don't understand our problems. How important it is to go to the movie theater before the start of the movie, right? How important it is. They don't understand. They still doesn't understand. Go watch the movie. Okay? So according to them, this emergency lane is part of lateral clearance. It's not part of the road. Okay? So if you have the yellow line, the lateral clearance is started. Okay? The 5 or 6 or 10 feet of the emergency lane is part of lateral clearance. Okay? So it will be from the yellow line to the sidewalk. Clear? So, the factor comes from this table. We need the value of the lateral clearance and we need the number of lanes. Okay? And everything is per direction. Okay? So, lateral clearance on the right hand side of your direction. Clear? The last factor, it's not a factor, it's a value. It's a value. And the value is for ramp density, ramps per mile. TRD stands for total ramp density. Total ramp density. Okay. Number of ramps per mile. Okay. How do we find out? I explained in the last lecture, it's written there as well. Okay. But we need the number of ramps per mile. There is no factor, just find out the number of ramps per mile and put it over there. Okay. So this equation is for freeways, for multi and highways. We have this equation. There are two factors which we already discussed. Which ones? Which factors were there in the last equation as well? Lateral clearance and the lane. Okay, lateral clearance and the lane. Now, lane width, no change. Same factor, same thing. Okay. For lateral clearance, yes, it means factor for lateral clearance, but it's not the same value. Okay. Here, lateral clearance is taken on both sides of the direction. Lateral clearance is taken on both sides of the direction. And you take the total. You can see it's written there. I need the total. Okay? So I need lateral clearance, I need the number of lanes. But I don't need it for one side only. I need it for both sides. You take it from here and take it from here and add them together. Got it? There? Okay. So this factor comes from here. Then we have a factor for median type, Fm. We have 3 possibilities here. You may have a median, so the last value divided. You may not have a median, then undivided. Okay? And you may have something between them, which we call as two-way left-hand lane. So there is an extra lane, an odd lane between the two directions. Okay, it's an odd lane between the two directions, and this lane is used for left turning by anyone, whether he is coming from this side or this side. Okay, I have Okay, so this white area, the white shaded area is the two-way left turn lane. Yeah. Okay, so if I'm coming from here, I'm coming from the other side, I can go to this lane and wait for my turn to take the left. Okay, so I'm waiting here, and once the side is clear, I will take the left. Okay, the idea is the straight traffic keeps on moving, it stops for nobody. The person who wants to take the turn will wait, but he is not waiting in the main line, he is waiting in the extra lane. He is not stopping anybody. Okay, so you are allowing left turn without any signal. Because if you put the signal, then you have to put the red for the other side. There is no red for other side. Nobody has to stop it. Okay, and you can use it from any direction which you want. Okay, now you can look at the factor two-way left turn lane and the divided. The factor is the last two. For the last two cases, the factor is same, right? For the last two cases, the factor is same. Okay. So if there is anything between the two directions, in this case there is a lane, right? If there is anything between the two directions, any separation between the two directions, whether it's a tree, whether it's a grass, whether it's an extra lane, whatever it is, it's considered as, or it takes the same ruling as a median. Okay? If there is anything between the two directions, even empty space, sand, grass, lane, right? It is separating the two directions, it takes the same ruling as a median. Clear? So only way we can have undivided highway is both directions are at the same line. They are exactly at the same line. Got it? Clear? Okay. Then the last factor is for access point density. So number of access points per mile. Okay. You take the number of access points you have, divide by the length of the segment. Okay. And again, number of access points for your direction. Everything is, as I said, per direction. The number of access points in your direction. Clear now? Now what are access points? Access points are unsignalized entry points. Access points are unsignalized entry points. Okay? So they are not the same as intersections. Access points and intersections are different. For intersection you are crossing. Entry is this. There is only this one. Okay? Intersection you will have to provide the crossing. Right? There is no crossing, and even this entry does not have a signal. Then you can call it an access point. So there is no crossing and there is no signal. This is what we call as an access point. So count how many access points you have divided by the length of the segment. Okay, access point density. Once you get the access point density, you come here and find out the factor. Okay. Now you can see the factors, or you can see the values, the access point density values, the first column. Okay. There is no range, right? The values are fixed, 0 and 10 and so on. Okay. So if your value is 12, then we will do what? Manipulation. Okay. Manipulation is applicable here. Now the only thing, so we discussed all the factors here. The only thing which needs some explanation is FLC. What did I say about the median? What did I say about the median? Huh? Anything? Yeah, anything which is separating, right? It's considered as a median. Okay? If it's considered as a median, then it becomes divided, right? It becomes a divided highway. So if I say undivided, that means there is nothing between the two lanes, right? They are at the same point. They are at the same point. Okay? So what is the lateral clearance here on this side? 0, right? There is no lateral clearance. Okay? But what is happening? I have factor for median and I have factor for lateral clearance. Okay? Now you take undivided and you are using it in both of these factors. Okay? The undivided is considered in both of these factors. So in FM, we have a factor because the highway is undivided. In FLC, the factor will change because highway is undivided. So you see duplication of effect. One thing affecting the same equation twice. It's the same thing, right? Undivided highway. Okay? It is affecting this equation in FLC and then in FM, both. Okay? So we don't want to have this. Okay? So what do? We take median type and divide it. Fine, no problem. Okay? But we will remove the effect from FLC. We will remove the effect of median from FLC. How? In FLC, the clearance on the left hand side is always taken as 6 feet for undivided. Okay? In FLC, you need total lateral clearance. So total means I will take the value from the right hand side plus 6 feet on the left hand side for undivided highways, always. Okay, so undivided highways is always 6 plus something. Okay, 6 plus the value you have on the right hand side. Got it? Clear? Any questions? Okay, so if it was 4 feet on the right hand side and it is undivided, the total will become 4 plus 6. Got it? There?
From the shoulder to the center of the highway, like to the median,
No, the lane. The last lane.
to the last lane.
To the last lane.
From right to left and from left to right for the
I'm measuring it for this side, the last lane here. I'm measuring it from here, and the last lane here. Okay? Okay, we will do 2 examples here, one for freeway, the other one for multi-lane highways. Okay? For the, start with the freeway, now you can see, it's a 6-lane freeway. Okay, lane width 12 feet. Lateral clearance 4 feet, ram density 4. Okay, I'll go to the equation of free flow speed. This is the equation for free flow speed. Okay, now if I look at the question, I need factor for lane width, factor for lateral clearance, and total ram density, right? Okay, the ram density is given. Rams per mile given. Okay, so this TRD will become 4. Okay, direct. No factor here. Okay. Whatever is TRD, I just put the value directly. Okay. Then there are 2 factors, one for lane width, the other one for lateral clearance. Okay. My lane width is 12 feet. Lane width is 12 feet. Okay. For 12 feet, the factor is how much? 0. The next factor is for lateral clearance. Okay. The lateral clearance, I need it for the right hand side only because it's a freeway, not the total. Okay, so for right hand side, the lateral clearance is how much? 4 feet, right? The third value. Okay, so for 4 feet, it's a 6-lane freeway, and lateral clearance is 4 feet. So 6-lane means 3 lanes in one direction. Okay, and 4 feet lateral clearance. How much? And how much is the value? Okay, any problem there? Okay. The next question is for the multi-lane highways. So I'll take the equation. Okay, which value I can put directly? Yes. Which value is given in the table I can put directly in the equation? Huh? Ramps? Yeah, where are the ramps? Okay, one thing you can see in the table, some values are not applicable from one type of highway to another type of highway. For example, you will not see ramps for multi-highway, right? You don't see median type for freeways, and so on and so forth. So you cannot switch them. Okay? Anyways, any other value which I can take it from the table and put it in the equation, correct? We are talking about multi-highways, only look into that column. Okay, last column. Which value from the last column can go into the equation? The base free flow speed. What is the base free flow speed? Is the maximum design speed. Or the design speed. Design speed is maximum, right? The maximum or the design speed. Okay? Clear? Base free flow speed means the maximum speed, the design speed. Okay? If you are doing it for a highway which will be designed in future, you will pick your design speed. Okay? You will pick your design speed. Okay? So this value is given, I can replace it with 65. Okay, the next factor was for what? This is for what? Lane width. My lane width is 11 feet, right? So for 11 feet, the factor is 1.9. Okay, letter clearance. What did they write about letter clearance? They gave me letter clearance right hand side, 2 feet. So letter clearance is 2.
At 6.
Why at 6? Why? Why did I say add 6 here?
Number of pens on 6. No, not 6.
Yes, why should I add 6 here? The answer is correct. You should add 6. What's the reason? If you don't know the reason, you will keep on adding 6 every time.
Undivided.
Undivided. Okay, you are adding 6 because it is undivided. If it's not undivided, you will not add 6. Clear? Clear? Okay. If it is not undivided, we will not add 6, but we will do what? We will add the value for the left hand side, exact value. Okay. If it is a divided highway, I need the exact value for the left hand side as well. Okay, and I will add that value itself. Okay, it will not be plus 6. It could be 8, it could be 9, it could be 0, whatever it is. Got it or not? Okay, plus 6 is only fixed for undivided height. So it will be 2 plus 6 here. But if it is divided, then you should ask for the letter clearance on both sides, separate. So you can add it. Clear or not? Okay. So right now it is 2 on the right hand side, left hand side I will take as 6. Okay, so total is 8 and it is 4 lane highway. 4 lane highway, 8 feet clearance. How much? I'm here, right? On the left hand side. How much? Where is it? 8 and 4 lane, 0.9, right? Okay, median type undivided, so the factor is 1.6. Access point. Access points are 20, right? So I'll take the factor of 20 access points. For 20 access points, the factor is 5. How much?
40.6.
Huh?
50.6.
40?
Yes.
Really? How? No.
Okay. 55.6.
Clear? Any problem? Problem? No. Clear? Okay. We will do 3 types of analysis in this chapter, formatting, handling, and freeways. In all these 3 types, this is the first step. First step is to find out what? What did we find? Free flow speed. In all these 3, the first step is to always find out free flow speed. Got it? Clear? And there are 2 ways to find out free flow speed. Use the equation or use the brain, huh? Field study, without the brain, right? With brain? Okay. Huh? Better without. Only muscle. Clear? Okay. These 3 analyses, what they mean: operational analysis, finding out level of service of an existing height. Operational analysis means finding out level of service of an existing height. Okay. Then we have the second one, service flow rate and service volume analysis, which means finding out maximum flow rate and maximum volume for each level of service on a highway. Finding out maximum flow rate and maximum volume for each level of service on a highway. And the third one is design, which means finding out number of lanes for maintaining a level of service on the highway. Design means finding out number of lanes to maintain a level of service on the highway. Okay? So in the first case, you are finding out the level of service. In the second case, you are finding out the flow rate. Level of services, all of them. A, B, and C. In the third case, you are finding out the number of lanes for the level of service. Got it? Okay? Clear? Now, which of these are you doing for your term project?
Design analysis.
Depends on you.
Design. See, he will do design and he will do in the flow.
Depends on you.
Huh?
Depends on you.
Already depended on me. I gave you what to do. Now tell me, what are you doing? Operation analysis? Yes. He's also doing the work.
It's all,
Yes.
You don't know.
Service flow rate.
See, he will do design, you will do service flow rate. Okay? And you have to do operation.
Okay. So operation is.
He will be free. He's just sleeping. Who is the best person in the group? And he's wrong.
All of them are bad.
He's the one who's wrong.
Faisal is the best.
Huh?
Faisal is the best.
No, I mean in terms of studies. He's the best person.
Yes.
In terms of studies? Yes, sir, right?
Studies?
Yeah.
Yeah, that's good. Sure.
You lost marks because
Yes. I was going to tell you right now.
and he's the one who's wrong.
Yeah.
We are not doing design.
This is carbon.
Huh? Yes. So he should lose marks, right?
He's a proud.
Okay, we are doing the first two. We are doing the first two, both. Okay? We You're doing the operational, but then you have to draw the speed flow curve as well, so you will do the second one as well. Okay, so you're doing the first one. Okay. In all three of them, I told you the first step is to find out free flow speed. Now I'll jump to the third step direct. Okay, and I'll come back to the second one. Okay, third step for each one is different. This is for operational analysis. Third step for operational analysis is to find out BP. BP means flow rate. BP means flow rate. Okay, so you already have a highway. So V is the peak hour volume of the highway. V, capital V, not the VP. Capital V is the volume of the peak hour on the highway. Okay. PHF is peak hour factor, N is number of lanes, and FHV is the factor for heavy vehicles. Okay. Factor for heavy vehicles. Okay. The units for volume vehicles per hour. How many vehicles we have on the road in 1 hour? And that is the peak hour. Okay. Units for BP, passenger cars per hour per lane. Okay. So you put V and you do this, and the answer you get is in passenger cars per hour per lane. Okay. It was in vehicles, right? Yes. It was in vehicles. Became passenger cars. Why? Because of FHV, factor of heavy vehicles. Okay. And then you also divide by N, right? N is number of lanes. So it became per lane. Okay, so from vehicles to passenger cars per hour per lane, right? But I am saying V is volume, and I am saying VP is flow rate. How did it become from volume to flow rate? What did they do? Yes? Peak hour factor. Okay? There's no.
I mean, no, not 4. Divide by 4 when we transfer the flow rate to 1.
Okay.
Forget.
Peak hour. Peak hour. Forget here. Okay, peak hour factor. Peak hour factor converts flow rate to volume and volume to flow rate. The 4 is for flow rate to flow. Here I am saying flow rate to volume. Okay. So volume to flow rate to volume, peak hour factor. Flow to flow rate to flow, 4. Okay. Clear everybody? Okay. So this is why volume became flow rate. Okay. This is the equation for operational analysis. These are the 2 equations for the second analysis, service flow rate and service volume. Okay. SF stands for service flow rate. SF is service flow. Then you see the letter I here, right? I belongs to level of service. Okay. You are finding out maximum flow rate for the level of service, right? Okay. So level of service could be A, it could be what? B and
C, D, F. A until F.
Until F. So I can put I as F here. I can put I as F here. Why not?
Initial final. You cannot.
Yes.
Until D, the level of service.
Huh?
The level of service until D, right?
People are at different level. This is like a
Because
completely new level.
they study every hour, not every day.
Yes. We cannot reach to F. Yes. We cannot reach to F. And we cannot reach to E. Because I gave the example of the grade, that's why. No, this goes to E, no problem.
Go for
Okay, it
us.
goes to E, but it cannot go to F. Okay? What condition is F? What condition is F? You will say.
Final, initial.
Fine.
Just a logic, like we take initial final.
It's not level of service, but I think volume of the capacity.
Volume of capacity, right? When volume falls above capacity of traffic jam, right? What is the purpose of flow rate then?
Okay.
There is no flow rate in the first place. There
Sorry?
is no flow rate in the first place.
There's no flow rate in the first place, and you don't know it in the second place. Okay. Okay, so it goes from A to E. Okay. SF, service flow rate. MSF, maximum service flow rate. Again, with the subscript I, so it can be for A and B and C and so on. Okay. So SF is service flow rate, MSF is maximum service flow rate, and the other two factors you already know. Okay. And S, number of
Lanes.
lanes, and FHV is a factor for
Just vehicle.
heavy vehicles. Okay. Now, what is the difference between service flow rate and maximum service flow rate? Both of them are flow rates, right?
Yes.
Okay. The difference is the condition. The first one is in the real condition. The second one, MSF, is in the ideal condition. Okay. SF, service flow rate in real conditions. MSF, maximum service flow rate, which is in the ideal conditions. Got it? Well? Okay. So the first equation gives you flow rate, service flow rate. The second equation gives you service volume. And how do you convert flow rate to volume? Okay, the same thing which we did in the previous equation. Okay, this is the equation for design analysis. Okay, and there is only one new thing here, which is what? No, as was there, right?
We took PDHV in chapter 1.
Yes.
Direction and our.
Because we are designing, so we need the design work. Because it's a design problem, so we need the design work. Okay. Everything else we already know. Okay. So I was saying this is the third step, right? Each equation is the third step. What is the second step? In all these equations, I need FHV. In all these equations, there is FHV here, right? So the second step is to find out FHV. What was the first step? Yes, free flow speed. Okay, the second step should be FHV, so I can use one of these equations. Okay, FHV is a factor for heavy vehicles. What is a heavy vehicle? Any vehicle which has, all vehicles are heavy.
When I write them.
Huh?
When I write them.
When you have them, you know, even without you cannot use them. All vehicles are heavy, right? Okay, but according to them, heavy vehicle is the vehicle which has more than 4 tires operating. Okay, the first one in your back, okay, 4 tires, so at least 6 tires. Okay, the small truck which has 6 tires, we call it single unit truck, SUT. Okay, and anything bigger than that is TT, trailer truck. Okay, anything having more than 6 tires is trailer truck. Up to 6 tires or 6 tires itself is single unit truck. Alright? How to calculate the factor of heavy vehicle? This is the equation. In the equation, you see there are 2 values needed, right? PHV and EHV. Okay? PHV is percentage of heavy vehicles. Percentage of heavy vehicles. Okay? Including both of them combined. EHV is passenger car equivalent. EHV is passenger car equivalent. Okay? Now, what is the idea behind it? The idea behind EHV, if you have 10 trucks and you have 10 cars, the number is same. But what about the effect? Which one will have more effect on traffic? 10 trucks, right? Okay? 10 trucks will have more effect, right? So, you cannot say 10 trucks is equal to 10 cars. 10 trucks is more than 10 cars, right? The effect of 10 trucks is more than 10 cars. Because trucks are slower and they are heavier and they are bigger, right? Okay. So, one truck is equal to multiple times a car. And that is EHV. The effect of a truck compared to a car. The equivalent effect of a truck compared to a car. That is EHV. Clear now? Okay. Now, for EHV, we have some tables from to find out the value. But before we go to the tables, you have to understand the truck itself is not the same on different terrains. When truck moves on level terrain, its movement is different than when it is going upward compared to when it is going down. Okay, even if it's the same truck. So the factor cannot be the same. Okay, so that's why before we find out EHV, we need to find out what type of terrain I have. There are two main types of terrain: extended grade and general. Two types of terrain: extended grade and general. Okay. Extended grade has one of these conditions. Okay. Extended grade has one of these conditions. Either this or this. If you fulfill this one, extended grade. If not, check this. If you fulfill this one, then it is extended. Okay. Now you can see you can only check one of them because your gradient can be either more than 3 or less than 3, right? You cannot have both. Okay. So first of all, you will look at the gradient and you will see, should I check this box or this one? Okay. Let's say I want to check this one. What am I checking? The length. Okay. So in the end, you are checking the length. Okay. There. Okay. Let's say my gradient is 4% and my length is 1 mile. So 4% means I am on the middle one, right? Okay, and my length is 1 mile. Do I fulfill it or not? My length is 1 mile. I fulfill the condition, right? So I have extended grade. Okay, clear? Let's say my length is 0.1 mile. Do I fulfill it? No. So I have generated it, right? Got it? Clear? Now if you are on this side, you again have two options. Rolling or level. Rolling or level. Now you already checked these, right? You are not here. So here, just need to focus on the gradient. Just need to focus on the gradient. If your gradient is less than 2, it is level. Anything else, it is rolling. Clear? So first check these two conditions. You don't fulfill it, then you come here. Just look at the gradient. Gradient less than 2, level. Something else, rolling. Got it? Going back to my example, 4% gradient, 0.1 mile length. Level or rolling? Rolling, right? Clear? Okay? Now, if we have level or rolling, now remember we are trying to find out the value of EHV, the passenger car equivalent of a truck. It depends upon terrain. So first of all, fix the terrain. My terrain is level or rolling. Then you come to this table, find out the factor. Okay, now let's say you are on this side of the table. Okay, you are not there, you are here. Okay, then you have a standard grade, right?
Yes.
So for extended grade, I have 3 different tables for EHV. Okay, in all of them, the data is same. You need the gradient, you need the length, you need the percentage of trucks. Okay, now what is changing? Tell me.
Numbers.
Okay, good. Numbers, yes. Which numbers are changing? Yes. Okay.
I found it, I don't know actually.
I found it, will not tell you. Yes. What is changing?
TTS and CUTS.
Yes.
It's TTS.
The percentage of single unit trucks and double trucks is changing. Okay. The mix is changing. This one is considered normal mix, default mix. Which one is higher? SUT or TT? SUT is higher. This is the normal case. Single unit trucks are higher, trailer trucks are less. This is called equal mix. Both of them are equal. This is called heavy mix. Trailer trucks are more. Got it? Okay. So you pick the terrain. If it is extended grade, then look at the mix. Okay. Now remember, the mix is for the heavy vehicles only. So I'm not saying this is 30 and 70 out of the total traffic. This is 30 and 70 out of the trucks only. Okay? If you have 10% trucks, this is 30 and 70 out of 10%. Okay? Otherwise 30 and 70, 100%. There are the cars. Okay? So then let us do a very small and simple example to apply this factor. Okay, FHV. We have rolling terrain, so no need to check the gradient element. Okay? 12% trucks, 3% average. In the equation you can see we are adding all heavy vehicles as one, right?
Yes.
Okay. The total percentage is 15. 12 plus 3, 15%. Okay. Then we have the volume which is there. Okay. But the volume is given in vehicles per hour. They are saying convert it to passenger cars per hour. Okay. There are two ways to do it. One is using the FHV. Okay. Now it's rolling terrain, right? Okay. I'll go to the equation of FHV. This is my equation. Okay. I need the percentage of heavy vehicles, right? 12% trucks, 3% average. Total 15. So this value is 15. Okay. Then EHV depends upon terrain. My terrain is rolling. So I'll go there. For rolling terrain, the value of EHV is 3. I'll come back. 3. How much? How much? Okay. Okay. Now I said there are two ways to do it, right? Okay. The first way is that you use FHV directly. So I calculated the FHV. Now my volume is 3200. Divide by FHV. This will convert the vehicles to passenger cars per hour. How much is this?
4,160.
This is now passenger cars per hour. The second approach is to use the EHV value, not the FHV, EHV value, the 3, the factor which I use in the equation. I can use it directly as well.
Yes.
Okay, how? This factor is for heavy vehicles, right?
Yes.
How many heavy vehicles I have? 15% of 3,200, right? 15% of the volume. So 3,200, which is how much?
480.
Okay, for these 480 vehicles, the factor is 3, right?
Yes.
The EHV is 3, so multiply by 3. How much?
1,440.
Okay, so from the volume, 480 were heavy vehicles, and the remaining were what? Cars. So I will add these cars here now. The remaining cars, okay? So plus 3,200 minus 480.
Yeah.
Okay, so you can use the FHV value or you can use the EHV value just to convert it to passenger cars. Okay, clear? Huh? Pictures taken? Huh? Okay.